Let's take this previous JEE Advanced question. It says the least value of alpha belongs to R, for which 4 alpha x square plus 1 by x is greater than equal to 1 for all x greater than 0. So let us consider this to be our function fx. So fx equal to 4 alpha x square plus 1 by x, and the function should be always more than equal to 1 for all x greater than 0. So for the time being, the domain of this particular function is x greater than 0, and we need to find the minimum alpha value so that this is always greater than equal to 1. Now first of all, you have to see that alpha must be a positive number, right? Alpha must be a positive number, because if alpha is negative, then you can easily see that as x belongs to plus infinity, this term will tend to minus infinity and this term will tend to 0. So overall the value will tend to minus infinity. So I cannot say that it will be greater than equal to a positive value for every x value. Right, so alpha must definitely be a positive number, that is for sure. So alpha is definitely greater than 0. Okay, and if we try to analyze what kind of graph it is going to be, you can analyze that limit x tends to 0 plus, limit x tends to 0 plus fx, just to the right of 0. What is the tendency? This is tending to 0 and this is tending to 1 by x is tending to plus infinity. So function is going to plus infinity, and limit x tends to infinity, fx will be equal to, as x tends to infinity, 1 by x tends to 0 and 4 alpha x square tends to plus infinity. So again it will be plus infinity. So the graph will start from somewhere plus infinity and it will end at plus infinity. Now definitely there somewhere the minimum value will be achieved. Where the minimum value will be achieved? Where the slope should be equal to 0. So we need to identify where the slope of the graph is equal to 0. That is a horizontal tangent can be drawn. So we need to identify where we will be able to draw a horizontal tangent. That means dy dx must be 0. So let us go for the derivative of the function. So f dash x is equal to 8 alpha x minus 1 by x square and equate it with 0. And this is happening at which value of x? Say x naught. So that x naught we can find out. So this is 8 alpha x equal to 1 by x square. So that implies x cube equal to 1 by 8 alpha. So that means x naught value will be, that x naught is 1 by 2 into alpha to the power 1 by 3. So this x naught value is 2 into alpha to the power 1 by 3, where the slope is equal to 0. And there is only one value of x where slope is equal to 0. So that should be a minimum point. That must be a minimum point. Let us further confirm that. You can easily find out double derivative. So double derivative will be f double dash x is equal to 8 alpha plus 2 by x cube. So what is the double derivative value at that point? So f double dash x naught. If I replace x by x naught, we will get 8 alpha plus 2 by x naught cube. And what is x naught cube? X naught cube is 1 by 8 alpha. So it will be 8 alpha plus 2 into 2 divided by 1 by 8 alpha. 2 divided by 1 by 8 alpha. That is 2 into 8 alpha. So it will be 24 alpha, that is greater than 0. So double derivative at that point is positive. What does it mean? It must be a point of local minima, and as for the graph it must be the global minimum also. So what is the minimum value of the function? What is the global minimum value of the function? So f minimum is equal to f of x naught. At this particular point x naught, function achieves the minimum value because dy dx is 0 and d2y dx square is positive. So what is the minimum value of the function? F x naught. So if you substitute in the function, it will be 4 alpha x naught square plus 1 by x naught. So if I substitute x naught value here, then it will be 4 alpha into 1 by 4 alpha to the power 2 by 3 plus 1 by x naught, that is 1 by 2 alpha to the power 1 by 3. So if you simplify, it is going to be alpha to the power 1 by 3 plus 2 alpha to the power 1 by 3 that is 3 into alpha to the power 1 by 3. So this is the global minimum value of the function. And we need to make sure that fx is always more than equal to 1. Function should be always more than equal to 1. How we can guarantee that? We have to make sure that the minimum value should be more than equal to 1. If the minimum value is more than equal to 1, then every other value must be more than equal to 1. So, to achieve this, we should apply the condition that is the minimum value of the function 3 alpha to the power 1 by 3 should be more than equal to 1. Cubing both sides, 27 alpha should be more than equal to 1. So, that will imply alpha should be greater than equal to 1 by 27. So alpha should be greater than equal to 1 by 27. So what is the minimum value of alpha? Minimum value of alpha is 1 by 27.